This is the third lecture from chapter 12, and we're picking up with talking about petroleum. So why petroleum? It is a mixture of a bunch of different hydrocarbons. So it's mainly going to be alkanes, cycloalkanes, so those would be the ones that have formed into circular molecules, ring molecules, and some of the aromatic hydrocarbons. So these are mainly going to be made out of the single bonded carbon hydrocarbon atoms, and like I said, and some aromatic hydrocarbons, but it's mainly going to be just the standard hydrocarbons. So we believe that most of today's petroleum that we're extracting came from the slow decomposition of buried marine life that decomposed in the absence of oxygen. This is different from coal. Coal came from the burial and slow decomposition and pressure pushing on plant life. So a little bit of a difference on how it's made, and that's why we ended up with different material. So instead we ended up with a liquid instead of a solid. So the petroleum, it's not actually just in a pool underneath the ground. It's actually in porous rocks, and then we call that an oil field where it's accumulated. It usually accumulates underneath a non-porous layer of rock. And the thing is that it turns out each of the oil fields has a different composition of hydrocarbons. So it's not like we go out and pull petroleum, pull crude oil from a oil field, and every single one is going to have exactly the same group of them that we're going to talk about in this section. So what we are pulling from it is what we call crude oil. So we call the material crude oil no matter what the oil field is that we're pulling it from. So it is going to be a mixture of different hydrocarbons. The upper limit is 50 carbon atoms. So none of the hydrocarbons that are coming in this crude oil are bigger than a molecule that contains more than 50 carbon atoms. That's the limit. We do have to refine this crude oil. We can't use it as it is. So this up here that you see coming out of this jug, that's crude oil. It's not usable in that form. And we refine it using boiling ranges, so using the physical property of these hydrocarbons. So, so what they do is they heat the crude oil and take it up through one of these fractionation towers. If you go into any of the areas where they're doing oil refinery, for example, I was down in Louisiana where there's a bunch of these, you'll definitely see these towers. So what they do is they heat it, and the crude oil vapors come into these distillation towers, and you get the heavier materials, the heavier hydrocarbons falling out, and so that would be things like asphalt and so forth. And then as the vapors rise through the tower, they're going to cool off at different levels, and that's going to be where they're going to pull. They only show some things, but they're going to pull different fractions of the hydrocarbons off as they cool at their different ranges. There's going to be up at the very top, the very lightest of the molecules, the very lightest of the hydrocarbons actually won't cool down and liquefy. And so these are going to be the gases that come off. And so here's going to give you a little idea of the products as far as the range of some of these. You can see they go from methane, that one carbon atom, in this case down to 20 carbon atoms, but like I said, they can go up to 50. So you can see over here, so there's that 20. Then down here we've got things like asphalt, which go up to 40 or more carbon atoms per molecule. So let's take a look at what kinds of things are being pulled out of this crude oil. So the smallest of the hydrocarbons that are going to be pulled off, depending on the makeup of the field, are going to be the one carbon atom hydrocarbon, methane, up to C4. So these are going to be gases at room temperature. So these guys are going to come off the distillation tower at the very top, the fractionation tower, so they will never liquefy on their own. They sometimes are pumped straight from wells as gas, but they will also be dissolved in the crude oil, and so that's how they extract them off of those fractionation towers. So 95% of natural gas is actually methane, the smallest hydrocarbon, the CH4. Then you can get liquefied petroleum gas, LPG, if you've ever seen that. And that's going to contain things like propane, so C3H8, and butane, C4H10. So those are going to be fractionated off to be used for different things. As I mentioned before, you're going to use these for things like cooking, and butane for lighters. So they're a much smaller fraction. Most of what's going to come off generally is going to be this methane. So then we're going to go up in size as we go here. So gasoline is a mixture of hydrocarbons that have anywhere from 5 to 12 carbon atoms. So it's a wider field of hydrocarbons. And when they are distilled from crude oil, they're going to be in their straight chain form. So you can see over here in the diagram, this is how they're going to come off the distillation process. So they're going to be in these straight chains. And you might be thinking, so what? Why do we care? The problem is that straight chain molecules burn really fast, and it causes what we call engine knock, and that actually can damage your engine. So what we want instead are these branched versions. So here you can see the branched version where there are carbons coming off of that molecule. This has actually got the same structure as far as the number of carbons, but it's actually, no, sorry, it's close. I was counting them and going, no, that's not right. So this is C7, this is C8, but you can see a very different structure. And so we can do the same thing to the C7, the heptane up here. We can reorganize it into this branched form. So the branched molecules are going to burn slower, and this is actually what we want in our engines. We want that slower burn to prevent the engine knocking. So this is related actually to a number you've probably seen and never really paid attention to. This is related to the octane rating. Octane rating for gasoline actually tells you how fast the gasoline is going to burn. And it's actually tied to whether there are straight chain molecules or branched molecules. So as octane rating of 0 means that you have all straight chain molecules, this N-heptane. An octane rating of 100 means that you have this other guy, this isooctane, or the trimethylpentane, which is the branched version. So the closer you are to 100 as far as an octane rating, the more of a slow burn, the more of an efficient burn, and the less of an engine knock, engine damage you're going to get. So this is why when you get to the gas pump, you see these different numbers. So, you know, you get 87 for your unleaded, 89, 91. So this 91 means that you've got a large amount of that branched chain molecule in that gasoline. This is why high performance cars require you to use premium fuel, this high octane rating fuel, because it will prevent that knock, it will prevent that damage. So how do they change the octane rating? Because when it comes off of the crude distillation factories, it's going to be pretty much 0 for the octane. Well, it's a process called cracking and reforming. So what they do is they're going to heat the straight chain molecules until they break. So they're going to add heat until they break, not until they ignite, until they break. And then they're going to use a chemical catalyst that stacks them basically into those branched forms, and so that we can get that higher octane rating. If you just do the cracking section, if you don't do the reforming part, you will get lower number hydrocarbons. So you get those lower guys like ethane and we have pentane, propane, and so forth. And we often will do this in order to get raw material for plastics. So this is actually one of the ways that we can expand our materials for our plastic production. We can also do cracking itself to get gasoline. So if we need to increase gasoline production, we can go and pull some of the higher number hydrocarbons that aren't being necessarily used and use the cracking process to break those bigger guys down farther and farther until they get into smaller sections, smaller hydrocarbons that then can be reformed using those catalysts to produce gasoline. The problem with that, we don't want to do that if we don't have to, because it increases the expense. And that's also why your unleaded is cheaper than your premium, because the more cracking and reforming that has to be done, the more expensive it gets to get that higher octane rating. All right, so what else can we get out of petroleum? Well, there's lots of products, and as I said, we're going up in number of carbon atoms. So as we go, the number is getting higher. So we can get things like kerosene. So that's going to get us things like lamp oil that you can see over here. This is also the section where you get jet fuel, heating oil, fuel oil, any of those kinds of types of materials. Next up will be diesel fuel. So diesel fuel is a larger carbon hydrocarbon, so it's got higher number than gasoline. And we use that for transportation, but also in heating. So there are generators that run off of diesel. Next, higher in carbon atom number is motor oil and other lubricating oils. So we do get these from crude oil. We can make them as synthetics now, and both those can actually be recycled. So they can be filtered and reused. And then petroleum jelly. So yes, it is called petroleum jelly because it is extracted from petroleum, from crude oil. Keep going. The next bigger one is mineral oil. So if you read the Johnson's Baby Oil, it will say mineral oil. This is extracted from crude oil. Paraffin wax. This is why it gets solid at room temperature. And it's because it's a large carbon hydrocarbon as far as the carbon number. So this is the stuff that we use for candles, but also the wax if you scrape wax off of waxed paper. And then the highest carbon number hydrocarbons in crude oil are the ones that come off right there at the bottom, and that is the asphalt. This is the stuff that we mix with gravel in order to surface our roads. So it's pretty heavy material as far as that goes. All right, that is the end of the section on petroleum. The next lecture will pick up with, as you can see here, hydrocarbon derivatives, basically what happens when we replace one of the hydrogen atoms with either another atom or with a group of atoms to create new products.